over x.
You can come up with something.
We know our definition. Our definition is just like f minus x is equal to something. Yes. Whether it is equal to f of x or minus f of x or negative or b.
Don't mind the background in the back, huh? So now we proceed. Huh? I believe we'll start from question 6. Huh? Okay, no, let's start from question 5C, since we didn't do this question with other groups. Huh? Yeah, so I'll send the solution after we are just done with the old table sheet. I think we'll be done in this meeting. Huh? Yeah, so now, if you have been given this question 5, it's asking us to say, solve the following simultaneous equation, isn't it? We've been given this part here. As you can see this part here, the y log base 2 of 8 is equals to x, right? Then there's also another one, this equation here, right? Which is 2 to the power x plus 8 to the power y is equals to 8,192. Now, what you do on this question is that, you know that you can't start working out this guy to your right-hand side, right? So we start with this guy, which looks a little bit easy to manipulate, isn't it? So using the log principles, we know that 8 can also be written in form of 2 to the power 3, isn't it? So when you have 2 to the power 3 there, it simply tells you that the 3 can drop, right? The 3 can drop, and then here you remain with log base 2 of 2, right? Now, log base 2 of 2, using that identity, it's just 1, isn't it? Yeah, so log base 2 of 2 is the identity, which you know that log base A of A is just 1, isn't it? When you have been given two things here, which are the same, the base and the argument, it simply tells you that the log is equals to 1. The 3 will drop in front to be 3y here is equals to x, isn't it? So this will be our equation 1. Now, when we get this guy here, our equation 1, we put it into this guy, which is our equation 2 now. We have something like this guy here. So we know that you can see that x here is equals to 3y, right? So now here in this equation 2 here, where there's x here, we'll put 3y. Eh? So now you come here again. Here on this equation 2, you put where there's x, we're putting 3y there. Plus 8 to the power y is equals to 8,192. Now, since you have noticed that here the 8, we can also manipulate it a bit. It's the same as you have 2 to the power 3. So it will be 2 to the power 3 times y, which is 3y here. Now, we have 2 to the power 3y plus 2 to the power 3y. We can easily factor the 2 to the power 3y since it's common, right? So we remain with 1 plus 1, isn't it? Is equals to 8,192. Now, when you are there now, you can easily say that 1 plus 1 is 2, isn't it? So when you divide 2, your right-hand side here, you get something like 4,096, right? So now this guy here is 2 to the power 3y. So now how do we manipulate this guy, the 4,096, that we want this guy to be in this form, 2 to the power 12. Now, how do we get this form? That's why I'm using this guy here. I hope you still remember your grade, is it grade 9, 10, 11, 12 work where you divide this guy here. When you divide this guy, you discover that the 2 repeats 12 times using this method here. So the 2 repeats 12 times. So now, when these guys repeat, so you have 2 to the power 12, because you know that this 4,096, when you say 2 to the power 12, it will give you 4,096 here. So now when you have that, you know that these places are the same. So which means the exponent as well, they are equal. So if you have 2 there, the index are the same. So which means the exponent as well, they are equal. So we'll say 3y is equals to 12 there. Now, when you have that, you now solve for y, which we just divide by 3, we get a 4 there. Are we okay? So you have found your y there. So now solving for x, we use the same equation. We have 3y is equals to x. There's an equation 3y is equals to x on top here. Here, this equation 1, 3y is equals to x. Know that our y here, it's what? It's 4, right? So if you know that our y is 4, we just put it there, isn't it? So it will be 4 times 3, which is this 12 here, as our final answer. Any questions, people? Okay, you can easily type the question if you have. Okay, to repeat, where should I start from? Everything? Okay, Mr. Chanda, you can go ahead, please.
Yes, I just wanted you to repeat. So, yeah.
Everything?
Yes, please.
Okay. All right, so we are here, isn't it? All right, Mr. Chanda, I'll go through again. But if you are not getting it, the video will be uploaded on Tiala's Congo. I'll send you the link on YouTube. I'm recording this one. Yeah, so let me try to repeat again. So I've been given these two simultaneous equations, isn't it? We have this guy here to the left and that guy to the right, right? So like I said earlier on is that you have to go for the one which will be easier to manipulate. So you know that you can easily manipulate this guy. You have seen him before. It's easy to do this. Now here we have 2 to the power x and 8 to the power y. It will be difficult for us to make anything or any useful equation which we can use to manipulate this log, which is this side. Will make our job hard or difficult. So like I said earlier, you know that, hey, this is 8, right? 8 can be written in form of 2 to the power 3. Our goal here is that one to match this base here. There's a base 2 there, isn't it? So you know that 2 to the power 2, the log of base 2 of 2, raised to the power 3, you can easily say the 3 will go down using the log principles. I believe you have seen them already. So now when the 3 goes down, here we remain with log base 2 of 2. Now, log base 2 of 2 is simply 1, isn't it? That guy will give you 1. 1 times 3y, which the 3y which has dropped, this guy you are getting. 3y here, which is equal to the x this side. This guy is our equation 1. Now, substituting into equation 2 now, we get something like this. So where there is x here, we have said that x is equal to 3y, isn't it? So when you see your equation 2, this guy here, our x there, it's 2 to the power x, right? So where there's x there, you put a 3y, the one you have found here in your equation 1, you put a 3y there, isn't it? So you have 2 to the power 3y plus 8 to the power y is equal to 8,192. Now, when you find that guy there, you can notice that that's 8, isn't it? And then you have an index here of 2. So you can easily try to manipulate this guy, the 8 here. So you have something like 2 to the power 3, right? Now, there's a power again, the y. So when you say 2 to the power 3 times y to give you 2 to the power 3y, isn't it? So when you reach that step here, you have noticed that the 2 to the power 3y plus 2 to the power 3y is the same there, isn't it? So we can easily say, we can easily factor out this 2 to the power 3y, and we remain with the 1 here plus 1, right? I hope you are seeing it. So when you are there now, you can easily say 1 plus 1, it's 2. Now, the 2 which is here, you can divide it to your right-hand side here, and you get something simple, right? You have 4096, isn't it? So when you have this guy here, if we were to put, imagine we were to put a 2 here, what exponent should we raise the 2 to so that we get 4096? So if you use this guy here, this division, which is this side, it will be easy for you. Since we don't use a calculator, so you can easily say this guy, 2 into this guy, 2 into this guy to give you something like 2000 and something there, isn't it? Without a remainder. So you continue doing the same. So you find that the 2 on this line here, your left-hand side, there will be 12. So you have noticed that 2 going to this guy 12 times. So when we say 2 to the power 12 here, you get something like 2 to the power 12 there, isn't it? So when you use your calculator, it should give you 4096. So we have something like 2 to the power 3y is equals to 2 to the power 12. So these indices are the same, isn't it? So it simply tells you that the exponent as well are equal. So now with the exponent are equal, you can easily say 3y is equals to 12 here, isn't it? Which is the same as y is equals to 4 when we divide the 3 to your right-hand side. Yeah. So now when you have solved for y, your next goal is you solve for x, isn't it? Now 3y is equals to x. This guy here, we'll find that our equation 1 on top here is 3y is equals to x. Here, this is our equation. So we substitute. Now, where there's y, we know that you put a 4. So here, when you put a 4, it's 4 times 3, which is the 12 there. That's how we are finding for x. So now we have been taught to solve the simultaneous equation. So we have actually solved it. We have found the values of x and y. Then we are done. Are we okay, Mr. Chanda? All right, you can just write the message if you are clear. Yeah. We proceed. Okay, we look at D now. Question D. Here we've been given this two equation, isn't it? It's the same method for everything. Yeah, I think for question 5, the D here, it's when you look at it, you know that when you start with this guy, it's like you won't have anywhere to go, isn't it? Because here there are complicated steps. If you try to start with your equation 2, which is this side, you try to solve for x. Now when you put it in here, it will be confusing. So we start with these guys here on your left-hand side. They are easy to manipulate. So now when you start with those guys, now log x minus log 2, using those principles. And keep in mind that here the base is 10 and here the base is 10. So when the bases are the same and you are subtracting, it simply tells you that here you have x over 2. We are dividing, isn't it? Here you are dividing. So you have, using those log principles, you have log x over 2. The minus there, it will go away, isn't it? Using those principles is equals to the 2, which is here, it will go up. Using those log principles again. If you have forgotten, look at them again. So you have log base 10 of y to the power 2. So now you continue now. So when you have that guy there, since the bases are the same, we can equate those two using the like there's the product, isn't it? And then this is the equality rule. Using the equality rule, you have noticed that here the base is the same as the one which is this side. So we can even assume that the arguments are the same. So if the bases are the same on both sides, you can even say the arguments are the same. So you just say here, x over 2 is equals to y squared. Yeah, since the bases are the same, so we assume that even the argument or these guys here, x over 2 and y squared, they are equal as well. Look at that principle again. The equality law, look at it. So when you have this now, you just solve for x, isn't it? When you do your manipulation here, you can just say cross multiply, right? So you have 2 times y, which is giving us x is equals to 2y squared. So if you have found that your x is 2y squared, since we have been given this equation 2 here, we can easily substitute it in this equation here. So we simply do this. We know that our x is 2y squared, isn't it? So where there's x, we put a 2y squared here, isn't it? Minus 5y plus 2 is equal to 0. So when you look at this guy here, you can easily solve it quadratically because this is a quadratic equation. Because here we have an exponent of 2, isn't it? So it's a quadratic equation. So when you do the manipulation, you will find that here you have okay, let me just go through them. So here you know that your sum is -5 and your product is 4, isn't it? The two factors are -1 and -4. Now, when you find those two factors, you can easily do those sums manipulation. You'll find that you arrive somewhere here where you have y minus 2, open and close the brackets, 2y minus 1, open and close, right, is equals to 0. So now this guy here, you can easily see that the y here, y minus 2 is this guy here, is equals to 0. So you can say that the 2 goes that side. So we have y is equals to 2, or 2y minus 1 is equals to 0. So the 1 can go that side. And then you have 2y is equals to 1. Now, the 2 which is this side, you can divide. That's where the half is coming from here. So since you have found the two values of y, we can now solve for x, isn't it? So we take first the first value of y, which is the 2 here. We put it in here, right? So we have in this equation, I hope you remember this equation. We have this equation here, isn't it? So now that we have found the two values of y, we can start with the 2, we put it there, right? So when you put a 2 in that equation, we have 2, since here the equation is x is equals to 2y squared, right? So where there's y, we put a 2, it's 2 squared now. So 2 squared is simply 4. 4 times 2, it's 8 here, the one you're seeing. Now, you have solved the value of x. Huh? Now, you solve for another value of x. Since we had two values of y, now you put another value of y in the same equation here. So when you put the half there, which is half squared, is simply 1 over 4. When the 2 multiply 1 over 4, you get the half again. X is equals to half. That is, you have solved that equation simultaneously. Any questions? Okay. Yeah, you should be texting your questions. Yeah, I've seen that people are complaining that I'm too fast. Yeah, so you can just text if you're not clear. I repeat myself in a slow motion now. All right, Mr. Miss Mlenga, you can ask, please.
Sorry, you're too fast. I couldn't get what you were saying.
Okay, so I repeat. Yes, Miss Mlenga, should I start from the start?
Yes, sir.
All right, let's go back.
Yes.
Okay. Yeah, so
Yes,
we start from here now, isn't it?
Yes.
Yeah, so you can see that here we have our equation 1. This is our equation 1, isn't it? And then this guy on your left, your right-hand side is our equation 2. So like I was saying earlier, that it is easier to manipulate these logs on your left-hand side. So when you manipulate these logs here, it will be easy now to find, you just substitute in these values which are on your right-hand side. Now, when you're solving for these guys on your left-hand side, so when you're dealing with logs, just remember that there are principles involved. So when you have been given log of x minus log of 2, we know that the base here on both logs is 10, isn't it? So if you know that the base here is 10, it simply tells you that using those log principles that when we're subtracting the logs, we can simply say that we can easily divide the argument. So here we start with this guy on your left-hand side, the x. So you have x over 2, this side here. So when you have that guy there, you simply know that, keep in mind that this is log of base 10, isn't it? Log base 10 of x over 2, right? I hope it's clear there. Is equals to the 2 which is in front here. It simply tells you that using those log principles, it can go up to this argument and becomes y to the squared there. I hope you can see the y squared there. So now when you have these two equalities, so it simply tells you that this guy is equals to that guy. So now using those log principles of equality or equality, so we can simply say that since the bases here on this guy on your left-hand side, it's 10, and the base here on this guy on your right-hand side, it's 10. So if the bases are the same, we can simply say that even the argument, this is the argument here, x over 2, and y squared. This is the argument. If the bases are the same on this equation, it simply tells you that the arguments are they are the same. So what you do there, if you know that the arguments are the same, you can easily equate them. So you can easily say x over 2 is equals to y squared, right? Yeah, so when you are there now, you have noticed that we have equated those two arguments, isn't it? So we now solve for x, isn't it? So solving for x, you can easily say x over 2 is equal to y squared. When we cross multiply, we have x is equal to 2 times y squared, isn't it? Hope it's clear there. So we have now solved. This will be our equation 1. Keep in mind that this is our equation 1. So since we have found our equation 1, we know that we have been given two equations. So here you can see that we have this guy here. We have managed to solve, to see that x is equal to 2 times y squared here, isn't it? So we can easily use this guy now to do our simple manipulation so that we solve for y, isn't it? So where this x here, we'll be putting 2 times y to the power 2. So here you can see that using that equation, this equation here, you're able to see that where this x here, we're putting this guy here. When you see this guy, we put it there where there's x. So we have 2y squared minus 5y plus 2 is equals to 0. So now when you look at this guy, it simply tells that the power there is 2, isn't it? It's a polynomial of degree 2. Now, when you're dealing with polynomials of degree 2, they are called quadratic equation. So you can solve this guy using the completing the square method or the quadratic formula, or you can use the factorization method like the way I've used here. So you have something like sum is equal to -5 and the product is 4. When you look at here, our sum is -5, you put it there, and the product is 2 times 2, which is 4 there. So now, what are the two common factors that will give us? When we add them, they'll give us -5, and when we multiply them, they'll give us the 4, which is there. So the two factors are -1 plus -4. We're getting -5 there. Then -1 times -4, we're getting +4 there. So now when you have those two sums, you can easily say now, since here we start with this guy, the 2y squared, right? So 2y squared minus this guy. Okay, sorry, we are the network challenge. Yeah, so now we proceed now. Here you're able to see that we are looking at the two factors, which is -1 and -4 here. These are the two factors. So now using that factorization method that you all know, isn't it? You know how to manipulate these guys here. So you have 2y squared minus y plus -4y, isn't it? -4y plus 2, isn't it? So now, when you are here now, you can easily look for those factors which are common. You have noticed that y is on both sides here. You can factor out the y. You remain with 2y minus y. Then here you know that -2 is common. So you can factor out the -2. So remain with 2y minus y is equals to 0. So now you know that y, the 2y minus y and the 2y minus y, they are the same here. 2y minus 1, they are the same here, isn't it? So we can easily say that y minus 2, we open close, and then we open again, 2y minus 1 is equals to what? 0. Yeah. So when you have reached that stage, you can easily now equate them. You can start with this guy, y minus 2 is equals to 0. You come here, you solve. Y minus 2 is equals to 0. So we solve for y. How do we solve for y? We just say the 2 goes that side. So it will be y is equals to 2. Then we are here now. We have 2y minus 1 is equals to 0 using this guy here. 2y minus 1 is equal to 0. We get y, the one who comes this side, it will be 1, isn't it? It will be 2y is equal to 1. Now, if 2y is equal to 1, we can divide both sides by 2 so that we solve for our y. So y is equal to half here, which is there. So now, since we have found two values of y, when we substitute in our equation, this equation here, this equation here, we should get two values for x as well. So we come here now, we are substituting. Where there is y, we put a 2 because our first value for y was what? It was a 2 here. So where there is y, we put a 2. When we put a 2 there, we have 2 to the power 2, which is this 4 here. 4 times 2, it's giving us x is equals to 8 there. So now we know that x is equals to 8, isn't it? What we do next is we solve for another value of x, isn't it? So we come here again, we have x is equals to 2. Where there's y, we put a half. Since here our next value for y was half, isn't it? So when you put a half there, we have 2. What is half to the power 2? It's simply 1 over 4. Now, 2 times 1 over 4, it simply gives you the half because the 2 there, it will go into this guy here 2 times, right? So you have 1 over 2, isn't it? So it will be x is equal to 1 over 2 as our final answer. Any questions? Yeah. Oh, yeah. We proceed. Yeah? Wonderful. So we now go to our next question. Huh? So for E, I won't do much of the work, isn't it? Since it's the same concept. You know, the key is just to solve for this guy, which is on your left-hand side. You just have to do the manipulation there. The concept I've taught you, like there, you can just apply them. They will normally work, huh? Or they will just work perfectly there. So we'll just go to the next concept, which is, we'll go to question 6. Huh? For this one, you do it. I'll send the solution, don't worry. We go to okay, question 6. Huh? Question 6 now. We've been told to solve the logarithmic equation there, isn't it? So I want to solve this log which we've been given. We've been given log base A of x plus log base A of 4 minus log base A of 5 is equal to log base A of 12, isn't it? So we have noticed that these two guys, these logs are adding, isn't it? So now using that principle, we know that when two logs are adding, if the bases are the same, we can easily multiply the argument. So it will be 4 times x, isn't it? That's why we're getting this guy here, the 4x, and then we maintain the base of the log here. Log the base A of 4x, isn't it? Then we also maintain this guy here, minus log base A of 5. Then this guy, when it comes to the left-hand side, it will be here. Since it's positive there, it will be minus log base A of 12 is equals to 0. So now, when you are there now, you can easily see that here there's a minus and here there's a minus, isn't it? So we can easily say that, okay, since the minus is common here and there, we can easily factor it out, isn't it? So when we factor out the minus there, we have log base A of 4x minus open log, positive log base A of 5 plus log base A of 12. So now since we are adding here, using that principle again, when you're adding logs, you can easily multiply this 5 times 12, these two arguments. That's where the 60 is coming from here, because 5 times 12 is 60. So now we have just remained with this guy now to do the manipulation for this guy. So we maintain the same guy. We have log base A of 4x minus log base A of 60 is equals to 0. So now since we're subtracting here, we know the principle now. When we're subtracting, we divide the arguments. We're not multiplying. When we're adding, just keep in mind that when we're adding the logs of the same base, we simply multiply the argument. When we're subtracting the logs of the same base, A and A here, we'll simply divide the argument. So it will be log base A of 4x over 60. Now, what is 4x over 60? We can easily simplify this guy. Since we know that we have the log here, isn't it? We have log base A of 4x over 60. Now, using that principle now, there's a log which is this side, isn't it? So we can take it this other round. So here it's 0, isn't it? So it will be A to the power 0. Now, what is A to the power 0? What is anything less to the power 0? It's simply 1. Always keep that thing in mind. Any number less to the power 0, it's simply 1. You can even say any letters less to the power 0. It's simply 1. It will never change. So you know that 4x over 60 is equals to 1. Hope we are clear there. Now we just solve for x, isn't it? So we can say 4x over 60 is equals to 1. We cross multiply 60 times 1. We're having 4x is equals to 60. Now, what is 4 into 60? 4 into 60 is given as 15 here as our final answer. Any questions? Yeah, so we have something like this. Let's do this. So we know that the A which is here, hope you can see it. When you have your A here, isn't it? So in order to get rid of this log, which is this side, using those log principles we did in our first tutorial, you know that the log, the base here, when you have a base here, when you take it to the right-hand side using that Snell principle, so we have A, the A which is down here, when it comes here, it will raise anything it finds this side, to your right-hand side, it becomes the exponent, and the A becomes as an what? As an index. So A to the power 0, what is A to the power 0? Anything less to the power 0, it's what? It's 1. That's why anything here, when you look at this guy here, if here there was a 2, when we take it this side, it would have been 2 to the power 0, isn't it? The 0 is already there in our equation. So we have 2 to the power 0. So anything less to the power 0, it's simply 1. Hope it's clear though. Okay, we proceed. Let's do another one. Okay. Okay. Oh, yeah. Let's do this one. So we've been given this equation here. Yeah. So when you have this equation, we know that log base A of x minus log 4. Now imagine what could be here now. Know that what is the 4 raised to here? The 4 is raised to the 1, isn't it? Then now using that principle, if the 4 is raised to the 1 here, isn't it? Which means here as well, there's a 1 there, but it's not just showing, it was just like a trick. Just trying to see if you're applying those log principles, isn't it? So there is a 1 here. Now log of anything, or log, if you have an argument of 1 there, isn't it? Which is hidden, there's a 1 there which is not shown. So log base A of 1, it's simply 0. The log of a 1, log of 1, it's always 0, no matter the base. It always gives you a 0 here. Using that principle, I remember you wrote something like log base 10 of 1 is always 0. Now, using that same thing, we know that you are having log base 4 here of 1, it's giving us this 0 here. That's where it's coming from. So now when you subtract these two, you are getting this guy here. Log base 4 of x is equals to 3 over 2, which is here. So now when you have this, using that Snell principle, you know that the snail goes like this. It goes as if it's going round, isn't it? So now it starts from the base is positive. When the 4 comes this side, whatever it finds to the right-hand side, it becomes an exponent, or it becomes the power. So it will be 4 to the power 3 over 2, which we are seeing here. 4 to the power 3 over 2. And then this guy, the argument will remain on your left-hand side alone. The log will go away. So we have simply gotten rid of that log, which was to the left-hand side. So now what is 4 to the power 3 over 2? We know that the 3 can easily come out. We can factor out the 3 here. We remain with 1 over 2, right? So 1 over 2 is simply the square root of 4, which is there, isn't it? Then the 3, which we said we have factored out, is there. You can see it. So it will be 3, the root of 4 to the power 3 right now. What is the square root of 4? The square root of 4 here, it's 2, isn't it? Because it's a perfect square. So that when you just say 2 times 2, you get the perfect square, which is 4, isn't it? So now, 4 to the power 3, what are we getting? We're getting 8 as our final answer. X is equals to 8. We have solved that equation. You get your full marks. Any questions? Okay, we'll proceed. Oh yeah, since this one is a little bit different, let me try to explain this one. The bases are not the same. So now we've been given on D, we've been told to find log base 9 of 4 plus log base 3 of x is equals to 3. So now, if you remember what we did in the first class, so you can easily say that you have base 9 there. How do we manipulate the 9? So you know that 3 to the power 2, I didn't show the 2 there, isn't it? So 3 change of bases, when you use that principle, change of the bases there, you know that it will be 3 to the power 2 here. Our goal is one to have these logs to have the same bases, isn't it? So there's a 3 there. Then you know that there's a way we can manipulate this base 9 here to get a 3, right? So we put 3 to the power 2. So there's a 2 here, which is hidden. Now, how do we get rid of this 2, which is there? So if we multiply 2 times half, we get a 1, which means the 2 will go away, isn't it? So what you do to your base, you also do to your argument here. So since here we multiply the 2 to the power half, we also multiply this guy 4, then the power of 4 is 1, isn't it? So 1 times half, it's simply 4 to the power half, the one you're having there. So now what do you do next when they're here? We know that 4 to the half, it's simply 2, because the square root of 4, it's 2, isn't it? So we have something like log base 3 of 2 plus log base 3 of x is equals to what? 3, isn't it? So now, using that principle again, we're adding here, isn't it? We're adding the logs of the same base. So it simply tells that we should multiply these two arguments. So when you multiply these two arguments, you have log base 3. Log base 3. When you multiply the two arguments, you have 2 times x. You have seen there, isn't it? There's a 2, there's an x. We're multiplying the arguments, right? So now, when you have this guy here, the log base 3 of 2x, isn't it, is equals to 3, isn't it? So now, using that Snell principle, don't forget, you can easily say this guy, which is down here, the base, when it comes like this, whatever it finds this side of your right-hand side becomes the power, itself becomes an index. So it will be 3 to the power 3. Now, what is 3 to the power 3? It's the 27, which is there, isn't it? Now, when you say 27, divide by this 2, so that we solve for x, isn't it? We are getting 27 over 2. You can leave it like that, because you have noticed that the 27, when divided by 2, it will give us a remainder. So you can leave it in that form. It's also okay. You get your full marks. Any questions? We proceed. Okay. Okay, this is okay. So now we are here, isn't it? We want to change this guy to the base that we want, isn't it? So we know that this guy, if we are to do the change of base, it's the same as we have log. Hope you are seeing that. We have log there, isn't it? That's a log. Don't mind my handwriting. Log base 9. Then here we have the index 4, isn't it? So if we want to change this guy to something that we want, we know that this guy, we can easily say that we have log base 4, isn't it? Over log of 9, isn't it? So we have something like that, right? So now when you have something like this, we can easily say that what base do you want here to put here and there? So we know that our base here, we have the base of 3, isn't it? So we want a 3 there, isn't it? So we can easily say here we put a 3, isn't it? Here we have a 3 there. And here again, we have a 3 there, isn't it? So now when we have noticed that this guy we can say is equals to, we have log base what? Base 3, isn't it? Log base 3 of 4 over log base 3. So we have noticed that the 9, you can write it in this form. We can say it's 3 to the power what? To the power 2. Here, that's a 2 there. So we have log base 3 of 3 to the power 2. Now, using that log principle, if you remember very well, it says that log base A here, that's A of A there, to the power, let's say 7. This guy here is equals to, it's equals to 7. Because this guy, the 7 will drop in front. Now, log base A of A, it's simply 7. Now, using the same principle here, we know that we have log base 3, isn't it? Of 4 over here, when the 2 comes down here, it will be 2 log base 3 of 3, isn't it? Now, we know that the log So we know that so we know that the log base 3, isn't it? Of 3, you know that this guy here is equals to what? 1. So you have seen that you have log base 3 of 3, isn't it? Log base 3 of 3. So we know that log base 3 of 3 is equals to 1. Now, what is 2? There's a 2 there, isn't it? So what is 2 times 1 here? So it will be just 2. So you have something like so here you have something like okay. So here we have log base 3 of 4, right? Over 2. since you know that the log base 3 of 3, it's simply 1 here, using that log property. So when you have a 2 there, we can easily say that here, we know that how do we get the 2, how do we get rid of these 2 down here? So when you multiply, so let's say if we were to say multiply this guy, the numerator and the denominator, right? So when you say half times what you do on your numerator, you also do it on your denominator. So you have 1 over 2, isn't it? So you know that this 2 and that guy, they will cancel. So here we only remain with this guy here. So when these 2 cancel, we have something like okay, so we have something like 1 over 2 log base 3 of 4, isn't it? So now when you notice this guy here now, we know that using that log principles here, you can easily say these 2 can go up, isn't it? Yeah. Yeah. So that 2 can easily goes up. So we have log base 3, 4, 3 power what? If we were to even put these guys here, to be 3 power 1 over 2. So that's how we got this guy here. So I didn't want to show all this process. There's a shortcut way which you can do this. You don't have to go through the same process when you are trying to change the base. So for you, your goal here is that you don't have to go through all these guys in order to get this guy, the 4 to the power 1 over 2. Like I said earlier, if you want to change this guy, you know that this guy here, it's 9, isn't it? What number can we raise 9 to? Can we raise 3? 1 to 3. What number can we raise the 3 to get a 9? So we know that 3 to the power 2, it's simply 9, isn't it? So the base is 9 there. So there's a 2 which is hidden. Now, when you know that there's a 2 as an exponent here to the base, right? So now what power or what number can you multiply the 2 with so that we get rid of this 2 here? We know that when you multiply by half, the 2 which was here to go away, isn't it? Then what we do to the base, we also do to the argument. So since here there's a 1 there, so we say 1 times half, isn't it? So we have 4 to the power half. The one we have just shown when I was doing the change of bases there. Is it clear now how to change bases? Okay, it seems there's no one who is. Yeah, wonderful. Just go through the video will be posted. I'll send you the YouTube channel. Yeah, you run it through again if you're not clear. Yeah, so now here we are here now. We know that the square root of 4, it's simply 2, isn't it? I think we have done this part. We even said that our final answer is this guy here. So we go to the next question. For the change of base, just go through the same video, you will know it. It's either use that way or you can use the shortcut way. Yeah, but shortcut are always nice in the exam, isn't it? They will save you time. So for question 6, it's the same principle, isn't it? So you just concentrate on the same thing, isn't it? Yeah. So use the same tricks or the same logs. Let's go to question 7. So for question 6, it's the same concept. It's just a change of bases. Okay, let me try to do this one. Yeah, I think this one is a little bit not flexible, right? Because you have a base 5 there, and there's a base x, isn't it? This side. Let me try to verify the top ones if they are okay. Okay. For question 6, is it E? Yeah, you see the solution. It's straightforward. But let me try to talk about this guy here. Question 6F. We've been given log base 5 of x plus 2 log base x of 5 is equals to 3, isn't it? So when you have been given such a thing here, you know that our goal is want to have the bases here to be equal so that we would simply do the manipulation, isn't it? So what can we do first? We have noticed that there's a principle which can work. There's a 2 there, isn't it? So the 2 can easily go up to the 5, right? So we have 5 to the power 2. What is 5 to the power 2? We know that 5 to the power 2 is 25. Huh? So we go back to this guy now. It is log base 5 of x plus log base x of 25 is equals to 3. What do we do here now? We want to change this guy here to have a new base, isn't it? What base do we want? If you have noticed, there's a 5 there, isn't it? So we want to change it to base 5. So now we know that when you're changing bases, you start with log. Want the base to be 5, isn't it? So I've log, like what I was doing earlier. Log, this argument, it will be on top, x. Then the 5, it will be here, down here. The argument 5, it will be here. This guy here, it will come down, the 5, and the x here, it will be the x there, isn't it? So now, here there's an x, there's a y or there's y. What base do we want here on both? It's a 5. So when you put a 5 there and the 5 there, we have achieved our goal. We also do the same here. We have 25 there, isn't it? To be log, want a base to be 5. We're changing the base here, isn't it? So we put a 5 of 25, isn't it? Then here again, we put a 5 of x, isn't it? When you are there now, what is it that you can do? You can now easily solve this guy. You can manipulate it. You know that the log base 5 of 5, it's simply 1, isn't it? So 1 divided by log base 5 of x, it's simply what? We're getting the same thing here. We have this guy here. This guy, it's 1, right? Then this guy, the 25, we can express it in this form, 5 to the power 2. So now 5 to the power 2 is simply 25, isn't it? Using that log principle, the 2 can drop, isn't it? So it will be 2 log 5, log base 5 of 5, isn't it? So now, using that principle that I taught you earlier on, you know that log base 5 of 5, when the base and the argument are the same, simply tells you that that log is equal to 1. So now 2 times 1 is what we are having down here. It is just 2. So we have this guy here, and then we have managed to manipulate this guy to be 2. Over what? Log base 5 of x equals to 3. Now, if you remember in our first class, I showed you how to get rid. When you see these things, there's a denominator here, which we don't like. We don't like to deal with this kind of denominator. What do? We multiply throughout by the same denominator, which is down here, so that it goes away. We don't want it there. So when you multiply throughout by the same guy, we have this guy, it is coming twice. So it will be log base 5 of x to the power 2 plus this guy to go away, isn't it? It will be log base 5 of x, it will cancel this guy, isn't it? So just remain with the 2 there, right? Is equals to 3. So now when you have that guy, we can easily say that since we have, okay, let's just say we can even use another method like the one I used here, where you have the common denominator, isn't it? So we have there's the 1 there. So 1 into that, it's 1. It's 1 into that is the same log. Multiply that by that same thing. It is twice, right? Plus this into that, it's 1. We're getting 2 there, right? Because 1 times 2, it's 2. So now when you multiply throughout by the same log, like what I was saying earlier on, it must give you this equation here. And I hope you can relate this equation. When you see this equation like this, we don't like to deal with logs. We can easily say, let this guy here, the one we don't like, the log base 5 of x be equals to t. So when we let this guy be equals to t, we can use this, where there's log here, we put a t, and also put a t there, isn't it? So it will be t squared minus 3t, because this guy it will be 3t. When it comes to the left-hand side, it will be negative 3t, which is there, plus the 2, which is already there, is equals to 0. So we can easily solve this guy quadratically, isn't it? What is our sum? Our sum is this guy, -3. Our product is 2. What are the 2 factors? What are the two factors? We know that our two factors is -1 and -2. When we substitute here, it is t squared minus t plus minus -2t plus 2 there, isn't it? So when you have something like this, what is common in this part? We know that t is common. We factor out the t. You remain with t minus 1, right? Then here, what is common? -2 is common, isn't it? So when you factor out the -2, we remain with t minus 1. So I've noticed that t minus 1, there's also t minus 1, it's common, isn't it? So I've managed to factorize. You have t minus 2, open close, t minus 1 is equals to 0. So when that guy is equals to 0, know that we can solve, isn't it? So t is equals to +2 or t is equals to +1. But we have not finished solving. We're not solving for t, isn't it? In our equation, we're solving for x, isn't it? So we bring back our log here. So it will be log base 5 of x is equals to t. Now, what is t? We know that t is t here is equals to 2. In our first part, in our first solution, set of solution, there's 2 there, isn't it? So we put a 2 here, isn't it? So now log base 5 of x is equals to 2. We know that using that trick again, when there's a base here of 5, we can easily say that the 5, it will come that side, to the right-hand side. So it will be 5 to the power 2. So x is equals to 5 to the power 2. Now, what is 5 to the power 2? 5 to the power 2, it's simply 25. So x is equals to 25. We have managed to solve the first part, which is equals to 25. Or we can easily say log 5 of x is equals to 1. The 5, it comes this side, to the right-hand side, it will be 5 to the power 1. What is 5 to the power 1? X is just 5, isn't it? So x is equals to 5. That's how you go about that question. Any questions? Are we clear on this one? Okay. We proceed. We go to question 7. We go to question 7. Now, question 7, it's asking us to find the quotient and the remainder for each of the following division problem. So here they have not specified which method you can use, isn't it? But we know that when this, the divider here, the 3x minus 2, we know that this guy here, isn't it? When you have the coefficient of 3 in front, it simply tells you that you shouldn't use the synthetic division. When you have the coefficient of 3 here, don't use the synthetic division, please. It won't always work. It will give you challenges. So when you have something like here, the coefficient is 3, use the long division, like the one I'm showing you right now. Yes, Mr. Thomas. Okay, you can just write the message, sir. Okay, we proceed. So this is our polynomial, isn't it? And then they're telling us that this polynomial should be divided by this guy here, this smaller polynomial, isn't it, of degree of 1, right? So we know that when we're dividing using a long division, isn't it? Yes, Mr. Eric. Hello? Yes, you can go on, please. All right, you can just send the message. So we are here now using the polynomial. Since keep in mind that here when your divisor or your dividend here or whatever it's called, it's the coefficient of x is 3. just know that you don't have to use the synthetic division. Okay, so I'll get back to some of the questions shortly, but the video will be posted on YouTube if you're not clear. Yeah, so now here we have something like when to use the synthetic or when to use the long division one, isn't it? So now when to use the synthetic is that when you have the coefficient here, let's say we're dividing this polynomial by this guy. So here when the coefficient is 1, you can use both. You can either use the long division or the synthetic division. But when you have the coefficient of 3 there, isn't it? Don't use the synthetic division, please. Keep in mind, don't use the synthetic division when here you have the coefficient of x is 3 or anything greater than 1. Don't use the synthetic division. Always use the long division. Are we clear there? Yeah, hope we are clear. So now, when this guy, like I said, the coefficient of x is 3 or it's greater than 3, we use the long division, right? So you know that 3 is greater than 1, right? So we say 3x minus 2. We do this long division. I believe you remember it. From what's this? Grade 7, isn't it? Okay. So now, okay. So people are not getting how we are getting. Yes, go ahead, Spear. Hello, Spear. Hello. Okay, I think there was someone who was having challenges on this part here. I'll just do a quick one because the video will be posted on YouTube. You can easily run through it. Okay, we've been given this this logarithm equation here, isn't it? What do we do when we've been given such a thing? We know that we have noticed that the bases are different, isn't it? So when the bases are different, we have to just keep in mind that we have to change. We have to ensure that the bases are always the same before we start solving. It will be easier for you to work with bases which are the same. Yeah, but there are some which you can easily solve. But for these ones, you have to ensure that the bases are equal. So we have noticed that here it's log the base x, and then here it's log the base 5. So now how do we change it? We can easily start with manipulating with the 2 here. So when the 2 goes up, it will be 5 to the 2, isn't it? 5 to the 2. Now what is 5 to the 2? 5 to the 2, it's 25 here, the one we are having here. We maintain these guys the way they are, isn't it? So log base 5 of x plus log base x of 25 is equal to 3. We have noticed that this x and the 5 are not equal. The bases are different. How do we change the bases? Using that principle I showed you. So we know that we have been given log. Here there's log, isn't it? I even showed you earlier on how to change the bases. You can easily follow through or watch the video again. So you can easily say that you start with this guy, the argument, the one you put on top here. So you have log of x, isn't it? Ignore the 5 for now. Imagine it's not there. Imagine the 5 is not there. So we have log of x over log of 5, isn't it? Now, what log can we put here so that we have the equal bases? So you know that if you use 5, it will be easier to solve for this guy, which is this side. It's 25, isn't it? So you know that 5 is divisible by 25, or 5 can go into 25 without leaving a remainder, isn't it? So if we choose our base to be 5, we can easily manipulate. You should always be careful when you're changing the bases. Make sure that the base you choose, it will be easier for you to manipulate. Because if you choose, like, for instance, a 2 here, you won't go anywhere. So only 5 will work for this base, for this change of base here. Always be observant of that. Don't change to a base which will be complicated at the end. So we put a 5 there, we put a 5 plus, we also change this guy here. So we have log 25 and log over log of x, isn't it? So here, when we are changing the base, isn't it? So we put a 5 there, we also put a 5 there. So when you are here, we know that we are home and dry, isn't it? So when you get this part here, the rest is porridge. What you do is that log base 5 of 5, it's simply 1, isn't it? So we have 1 there. And then log base 5 of x, we maintain it the way it is. We can't do any further manipulation on this guy. Plus log base 5 of 5 squared, isn't it? Now, what is 5 squared? 5 squared, we know that this 5 squared, the 2 can go down, isn't it? So we have 5 times 5 log base 5 of 5, isn't it? So now, what is log base 5 of 5? We know that log base 5 of 5 is simply 1. So now 1 times 2, this is the 2 we're getting. We don't do anything with this guy down here. So it will be 2 over log base 5 of x is equals to 3. So now here, when we put a 1 down there, we do that principle. When we're adding fractions, we can easily look for the common denominator. And we have discovered that the log base 5 of x times 1, which is here, it is just log base 5 of x. So now, when you put the denominator to be that, when we say 1 into log base 5 of x, we're getting log base 5 of x times the same log base 5 of x. So it is coming twice. That's why I've put like a 2 there. It's coming twice. Plus log base 5 of x into log base 5 of x. We're getting a what? A 1. So now 1 times 2, which is there, it is just 2, is equals to 3. So we know that here, we can easily multiply throughout by the same log base 5 of x, isn't it? So the log base 5, which is down here on the denominator, to go away, we have something like this part here, log base 5 of x, open close squared, plus 2 is equals to 3 log base 5 of x. So now, when you have this guy here, we know that we don't like to deal with these guys when they're in quadratic, isn't it? There's a square there. It will be difficult to deal with these guys. Okay, we proceed. So when you multiply throughout by this guy, you remain with this thing here. So now, we know that the moment you see it as squared there, isn't it? We can easily say, let log base 5 of x be equals to what? Be equals to t. So now, when you let that guy be equals to t, we substitute now. Where there's log base 5 of x, we put a t. So now, we say, where there's log here, when we put a t, it will be t squared, right? Plus 2 is equals to 3 log base 5 of x, isn't it? So it will be t squared minus, where there's this, we have put a t there. When it comes to the right-hand side, it will be minus 3t plus 2 is equals to 0. Hope it's clear there. When you take this guy to this side and you substitute for t, we have minus 3t plus the 2 there, which you will maintain is equals to 0. Then you solve it quadratically. You find your sum and product. So when you do that, you find two values of t. We have t is equals to 2 or t is equals to 1. But log base 5 of x is equals to what? T, isn't it? So we now solve for x, right? We're not solving for t. So now what is t? T is 2 and or t is equals to 1. So where there's 2t, where there's t, we first put a 2, right? So we have log base 5 of x is equals to 2. Now using that Casnell principle, isn't it? So that when the 5 is there, isn't it? This 5, when it goes to the right-hand side, it will be 5 to the power 2. Now, what is 5 to the power 2? 5 to the power 2, it's simply 25. So you know that x is equal to 25. So now, when we find the first value of x here, we solve for another value, isn't it? Because t was equal to 2 values, because the quadratic equation always gives you 2 values, isn't it? So now, where there's t, we put a 1 now. Here we have a 1, right? So log base 5 of x is equals to 1. So now when you have that, we know that the 5 can come this side to the right hand side. So it will be 5 to the power 1. Now what is 5 to the power 1? 5 to the power 1 it's simply 5, because any number raised to the 1 is simply the same thing. It's 5 to the power 1. Hope it's now clear on how to go about that question. We proceed now. We go back to our question 7. We were here. Yeah. So now, like I was saying earlier on, when you have something like the coefficient of x is greater than 1 here, if the coefficient of x is not 1, just keep in mind that if the coefficient of this guy, the x, is not 1, always use the what? The long division. But if the coefficient of x it's 1, you can use 2. You can use the long division or the polynomial. But keep in mind that the long division, when the coefficient here of 1, you can use the synthetic division. So now keep in mind that the polynomial, the long division one, always work for anything, for any polynomial you have been told to divide, it always work. But for synthetic, always use it when the coefficient here of x it's 1. So for instance, if we had something like we have the polynomial, for instance, we have 12, the same polynomial which is here, isn't it? This guy which is here, right? Now, if this guy were dividing it by okay. So now, if we're dividing this guy here, okay, so if we're dividing this guy by something like x, here we have x, right? Minus 2, isn't it? Then there's something like this here, isn't it? So imagine that this guy, it's your polynomial, right? This guy, it's your polynomial, isn't it? The one you are dividing by this guy, isn't it? So here, as you can see that here the coefficient of x is 1, isn't it? So what do you use? You use the synthetic division or the long division. The answer is always coming out correct. But in our case here, the coefficient is not 1, so we can't use the synthetic division. Keep in mind, guys, don't use the synthetic division when you have the coefficient here of x. It's still like the way it is. Use the long division. Hope it's clear. Okay, so now when dividing a polynomial, isn't it? So we always start with this guy here. So when we're dividing, we say 3x into 12x squared. We know that how many times can 3x goes into 12x squared? You know that it goes there 4 times. Then the x and x, it goes there 4 times. Then how many? Okay, let's just start with 3. 3 into 12, it's 4, right? And then x into x squared, it's just x, because the x will cancel, isn't it? So you have x squared over x. The x will cancel, you have 4x, isn't it? So when you are here now, we say 4x times 3x squared, isn't it? It will give you 12x squared. So when you have 12x squared there, we can easily say that when you multiply this guy times that is 12x squared, right? You also do the same to this 2 here. 12x squared, we say 4x times negative 2x. We're getting what? Minus 8x, isn't it? We're having 8x here. When we say 4x times negative 2, we're having minus 8x there. So now when you have something like this, isn't it? We simply subtract. We want to get rid of this part here. When you subtract these two, you know that the x squared and the x squared and the 12 will go away, isn't it? So you say these guys will cancel, isn't it? Now, 7x minus negative 8x, isn't it? So the negative and negative becomes positive. 8 plus 7 is 15x, isn't it? So when you have your 15x here, we know that we can divide again. Since the coefficient here, so for the polynomial, always keep in mind that when you have not reached a constant here, you keep on dividing until you find the constant. But here, if we had an x squared, okay, I'll show you an example for that one. So we say now 3x into 15x, it's simply 5, isn't it? Now, when you have 5, it is positive 5, isn't it? Plus 5, isn't it? Now, 5 times 3x here, which is there, we're having what? We're having 15x. And then we say 5 times negative 2, we're having what? Negative 10. We drop down this 10, which remained there. It comes down, isn't it? So it becomes minus 10 as well. So when you subtract, this 2 will cancel, isn't it? So it will be negative 10 minus, open, negative 10 again. Negative and negative, it's positive. So negative 10 plus 10, it's simply 0. So in this polynomial of ours, we don't have what? The remainder. So we know that the remainder is what? It's 0 here, isn't it? There is nothing, it's 0. So here the quotient is 4x plus 5. We always take the quotient to be this guy here on top, isn't it? That's our quotient. And then the remainder is 0. The one which will be down there is always your remainder. That's how you do with the polynomial using the long division method. Hope it's clear. Any questions? Mr. Anthony. Yes, sir. Go ahead.
Sir, are we done with the logarithms one?
Huh? Come again, sir.
Logarithms here?
We start with?
I'm saying that are we done with the logarithms?
Yes, we are 7
logarithms. Are we done?
Yes, we are done, sir. Their own question is it
so
6 and 5?
We have started now polynomials.
Yeah, we have gone into polynomials, sir. Are the logarithms
so if you have
okay?
equality.
Come again, sir.
Okay, sir, we just inbox you, I'll just inbox you.
Okay, all right, sir, no problem. Huh? I'll send the solutions for the logarithms. If you have challenges, please tell me.
Inbox.
All right, sir, thank you. Okay, let's try this one now. Here now, we have something like this, isn't it?
Inbox.
Okay, so yes, Madam, go ahead. Madam Linda. Hello? Shalon, you can go ahead.
I just wanted.
Okay. The network is really bad. Huh? Okay. Come again, please. Yes, Sharon. Okay, you can easily text me, or you can, send your question via text. I'll see it. Yeah, so when you have something like this, dividing into this guy here. So we simply take this guy here, we put it there, and then we take this guy on your left-hand side, we put it in here, isn't it? So we have something like x squared into this guy. X squared into this guy, we're having 3x, isn't it? So now, 3x, which we have found here, times x squared, we're having what? 3x to the power 3 there. So now, when you have that, we simply go on to say 3x again times this guy here, the 2x. Don't forget the 2x there. 3x times 2x, it's 6x squared. Are we okay there? Hope we are. So now, when you have something like it, we can subtract now. So now, 3x cubed minus 3x cubed, it's 0. We don't show it. Then we go on to say 2x squared minus 6x squared. Now, 2x squared minus 6x squared is giving us what? Negative 4x squared, isn't it? So when you have something like this here, we know that we can now divide again by this guy. X squared into negative 4x squared, we're having negative 4, which is up here. Negative 4 times x squared, we're having negative 4x squared, which is down here, isn't it? So when you have something like this, you multiply again, negative 4 times positive 2x here. We have something like negative 8x there, isn't it? Negative 8x there, you're able to see it though. Negative 4 times positive 2x is negative 8x there. So now when you subtract these two, this guy and that guy, we're having a 0. So we have negative 5 minus 8x, isn't it? When the 5 comes down here, we have minus negative 5x minus open negative 8x close, isn't it? So now negative and negative is positive. So it's negative 5x plus 8x, isn't it? Which is giving us what? Positive 3x, isn't it? The negative 1 will come down. You have 3x minus 1. So now here the power for this guy, it's 1, isn't it? But here for this guy, the one we're dividing is power 2. So it means we can't go further with the division. Hope it's clear that when this power is reduced such that this guy is smaller than the one we're dividing with, we don't proceed. That guy becomes our remainder. This guy is our remainder. We end there. We don't divide further. So now we just take the quotient, this guy, 3x minus 4, to be our quotient, and the remainder is what? 3x minus 1. The remainder is 3x minus 1. Then you're done. You even get your full marks. Are we okay with this one? Okay.
So how do you mix the remainder in the equation?
How do we? Come again, please.
How do you write the remainder in the, let's say if you are using synthetic division.
Okay. If you're using synthetic division.
Then there's a certain question I saw where you have to mix the remainder in the equation. The answer you get from dividing, then you also add the remainder at the end. How do you write that equation?
That's question what? So I'm getting there.
Okay, sir.
Yeah. So the remainder for this one, you're able to see it though. Hello? Okay, we proceed. Yeah? So now we go to question 8. Yeah? So we are done with question 7. We have gone to question 8. Yeah? Hopefully you guys, you have the energy. I'm hoping to finish this tutorial sheet today so that the next time we meet, we start tutorial sheet 5. Huh? Yeah, so you guys, I don't know, just take a drink nearby. Huh? When you're tired, sip some water or drink. Huh? Yeah. So now for question 8, here they have specified to say, use synthetic division to determine the quotient and the remainder for each of the following. So if you have noticed those question 8, you have noticed that x there on the, what's this, on that polynomial, which is x there, you have noticed that the coefficient is 1. No wonder they have been specified. Use synthetic division. Here the coefficient is 1. No wonder we're using synthetic division, isn't it? If you have noticed question 8, there's no coefficient which is probably 2 there. Or coefficient, they are just 1. So we're using synthetic. And then I believe you guys know how to use synthetic because it's the simplest. So what you do with synthetic is that you first equate this guy here, this factor of yours, be equals to 0. So when you say that this guy is equals to 0, say you solve for x. X minus 1 is equals to 0. When the 1 goes to the right-hand side, it becomes positive. So x is equals to 1. So when you do that, you now write it in this form. This one here for x, you put it in front there. Now the coefficient for your polynomial are 3, you put a 3 there. The coefficient for this x here, it's 1, right? You put a 1. The coefficient for this constant here is negative 4, so it's just negative 4. You put it there. Then 1, the first thing you do is you drop down this 3 when you're using the synthetic division, isn't it? You drop down the 3, then you start. 1 divided by 3, it's 3, isn't it? You put a 3 there. So now 3 plus 1, it's 4. You get it? And then you do the same again. 1 times 4 here, sorry. 1 times 4 here, 1 times 3, it's the 3 we're getting here. 3 plus 1 is the 4 we're getting. 1 times 4, we're having what? 1 times 4 is the 4 we're getting here. So now 4 minus 4, we're getting a 0 there. So now writing this guy using the quotient, you know that it will be 3 plus 4, isn't it? Now here, the x here, we have the x here, isn't it? It will reduce to 1, isn't it? So it will be 3x plus 4. Hope it's clear. 3x plus 4. The remainder here, while you have constant, this guy is always the remainder. So remainder for this equation, it's 0. Hope it's clear for synthetic. I believe you guys have gone through this synthetic division. It's simple, right? We'll proceed. Okay. For this part, it's synthetic. I will skip it. If you have challenges, I'll send the solutions. Don't worry. I'll skip this part because it's the same concept. Okay, we got to question 9. For question 9, they're saying that use synthetic division to show that g of x is the factor of f of x and complete the factorization. So now how do we do that? So if we want to prove that we have been given this guide, want to show that it's the factor of this guy, what do we know about factors? You know that the factor theorem states that, now the question here is saying that use the synthetic theorem to show that gx is the factor of that. So you know that the factor theorem is always equals to what? To 0. So you have x minus 1 is equals to what? 0, isn't it? So you solve for x. So x is equals to 1. Now, in the question that was specified to say use synthetic division, isn't it? So when you have that, you come here. When you see that the coefficient for this guy is 3, you put 3 there. The coefficient for that equation, which is question 9b, the coefficient for this guy is 3, you put the 3 there. There it's 19, you put 19. There it's negative 38, you put negative 38. Then you take the constant at the end, it is minus 16, isn't it? And then now you start doing those stuff, isn't it? So here we know that our factor, it's 1, right? So it's, we drop down the 3, isn't it? So 1 times 3 is 3. The 3 is there, isn't it? So 19 plus 3, we get a 22. Now 22 times 1, it's 22. Now negative 38 minus, negative 38 plus 22 is negative 16. Negative 16 times 1 is negative 16. So now when you say negative 16 minus negative 16, we're getting negative 32. So now what would be our conclusion here? We want to prove that g of x is a factor. Is that a factor? We have the remainder here. The negative 32 is our remainder. So what's our conclusion? We know that the quotient is 3x squared, the 3x there, isn't it? Plus 22x minus 16, our constant, right? I hope you know how to go about this, how to put the coefficient there. If you have challenges, please contact me, or you can use WhatsApp. So this guy is our quotient here. Now, the remainder is negative 32. Now, since x minus 1 is equal to g of x is not a factor, you know that a factor will always give you a 0. So now here it's giving us the remainder to be negative 32, which is not equal to a 0. So therefore, g of x is not a factor of that polynomial. There are other factors, but g of x is equals to x minus 1 is not a factor for that polynomial. So that's how you conclude on B. That's not a factor. Now, let's look at something which has a factor now. Question 9D. When you notice that g of x is equals to x plus 2, isn't it? And then f of x, our function, is this guy here. So now, if this guy is our function, you know what to do. X, we say we equate this guy here is equals to 0. X is equals to what? Negative 2. So now we put our negative 2 there. So it's 12, 29 there, 8, and negative 4 there. So the 12 will come down. The 12 will drop, isn't it? So now, negative 2 times 12 is negative 24. Now, 29 plus negative 24, it's 5. 5 times negative 2, it's negative what? Negative 10. Negative 10 plus 8, it's negative 2. Negative 2 times negative 2, it's positive 4. 4 minus 4, it's 0. So here you're able to see that g of x is a factor of f of x. You're able to see that we have found our 0 here. So we have shown that it's a factor. When you just get a 0 there, you know that g of x is a factor. So now, when you look at this guy here, they're saying that use the synthetic division to show that g of x is a factor and complete the factorization. So now, when you know that 4x squared plus 5x minus 2 is equals to 0. So now, I want to complete the factorization using the last part now. What is our factors? We know that our factors are negative 3 and 8. So now, when you do the factorization, I believe you guys by now you're good at factorization. So when you do those factorization, you find that you have 4x minus 1 when you do the manipulation for this guy. So here, we're able to see that, okay, what's common in these two here? You know that 3x, it's common, right? So you remain with 4x minus 1, isn't it? When you factor out the 3x here, you remain with 4x minus 1. And then here, when you factor out the 2, you remain with 4x minus 1 as well. So we know that 4x minus 1 is one of the factors. And then you also know that here there's 3x plus what? Plus the 2, which is here, the one you have factored out, which is we have here. We have 3x plus 2 when you do the factorization. Then we also multiply it with the x plus 1, which is our g of x, isn't it? Here, we have this guy here, isn't it? I believe for this guy, there was a typo error. It's supposed to be a 2 there, isn't it? It should be 4x minus 1, open, close, 3x plus 2, open, close, x plus 2. We also multiply it with this factor we have on top here, the one we are using. There it was a typo error. You should I'll send the correction. Yeah. Hope it's clear. Any questions? Okay. I believe people are tired. So I think I'll arrange for another meeting. Probably let's make it Sunday. Yeah, I think Sunday we'll meet again so that we just finish up this tutorial and we also start tutorial sheet 5 on Sunday, isn't it? Hope it's okay with everyone. Sunday, let's just start 17. Yeah, so that we allow those people go to church when they come back around 13 to rest some. So at 17 we start. We finish up this tutorial. Okay, so